All right, let's look at the molecular polarity for SF4. We have a formula, but we need a Lewis structure to understand if the arrangement of electrons around the center atom is symmetric or asymmetric. So the first step in drawing a good Lewis structure is adding up your valence electrons. We know that sulfur has 6 valence electrons, plus we have 4 fluorine atoms, and each of those fluorine atoms has 7 valence electrons. If we add that up all together, we have 7 times 4, that's 28, and 6 more, we have a total of 34 valence electrons that we get to play with. All right, now step 2. We're gonna go ahead and put the different atom in the middle. That's our sulfur. We're gonna put sulfur in the middle and we're gonna bond each of those fluorine atoms to it. 1, 2, 3, 4. We've just used up 2, 4, 6, 8 electrons out of that 34. So we're gonna take 34 minus 8, that leaves me with 26 more electrons I get to use in my Lewis structure. The next step in drawing a good Lewis structure, fill the octets of those outer atoms. So we're gonna go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And we're gonna take 24 away from my running total. I have 2 electrons left. Any leftover electrons need to go on that center atom as a lone pair. So I'm gonna put 1 lone pair on my sulfur. Now that makes sulfur have more than 8 electrons around it. We've expanded sulfur's octet, but that's okay. Sulfur is in the 3rd row of the periodic table. Elements in the 3rd row or below are allowed to expand their octet, so this is fine. Now if I'm trying to determine the polarity of this, already I know. Anytime you'd have just 1 lone pair of electrons, that cannot be a symmetrical arrangement around the outside, around that sulfur atom. So it's going to be polar. Now, if you want to prove it to yourself, well, let's just take a look. You've got 1, 2, 3, 4, 5 electron domains around your center sulfur. 5 electron domains is a trigonal bipyramidal arrangement. You're going to have a central sulfur with 1 area of electrons top, 1 bottom, and 3 in a ring around the middle. Now that lone pair of electrons, it needs a lot of room. So we put that lone pair on the equatorial positions. Here's going to be that lone pair of electrons right here, which means the 4 fluorines is going to be top position, bottom position, and the 2 remaining equatorial positions. Now, the pull of electron density towards the top, that's going to go ahead and cancel out the pull of electron density on the bottom. However, the pull of electron density towards this fluorine and that fluorine, well, there's no other fluorine right here in the middle to counteract those individual dipole moments. Since we don't have a equally balanced 3-way tug of war in the middle, there's an overall pull of electron density, and this molecule, in fact, has an asymmetric arrangement of electron density and will be a polar molecule. I hope that helps. Take care.